Section 2.8, Naming Inorganic Compounds. The names and chemical formulas of compounds are essential vocabulary in chemistry. The system used in naming substances is called chemical nomenclature, from the Latin word nomen, name, and colare, to call. There are more than 50 million known chemical substances. Naming them all would be a hopelessly complicated task if each had a name independent of all others. Many important substances that have been known for a long time, such as water and ammonia, do have traditional names, called common names. For most substances, however, we rely on a set of rules that leads to the information of a unique name for each substance, a name based on the composition of the substance. The rules for chemical nomenclature are based on the division of substances into categories. The major division between organic and inorganic compounds. Organic compounds contain carbon and hydrogen, often in combination with oxygen, nitrogen, and other elements. All others are inorganic compounds. Early chemists associated organic compounds with plants and animals, and inorganic compounds with the non-living portion of our world. Although this distinction is no longer pertinent, the classification between organic and inorganic compounds continues to be useful. In this section, we'll consider the basic rules for naming three categories of inorganic compounds: ionic compounds, molecular compounds, and acids. Names and formulas of ionic compounds. Recall from section 2.7 that the ionic compounds usually consist of metal ions combined with non-metal ions. The metal ions form cations, and the non-metal ions form anions. Cations. Cations formed from metal atoms have the same name as the metal: the sodium ion, the zinc ion, the aluminum ion. If a metal can form cations with different charges, the positive charge is indicated by a Roman numeral in parentheses following the name of the metal. Fe2+ is iron 2 ion. Fe3+ is iron 3 ion. Copper 1 is copper plus 1, and copper plus 2 is copper 2 ion. Ions of the same element that have different charges have different properties, such as different colors. Figure 2.23. Different ions of the same element have different properties. Both substances shown are compounds of iron. The substance on the left is iron 3 oxide, which contains iron 2 oxide, which contains iron 2 and iron 3 ions. The substance on the right is iron 3 oxide, which contains iron 3 ions. Most metals that form cations with different charges are transition metals, elements that occur in the middle of the periodic table from groups 3b to 2b. The metals that form only one cation, only one possible charge, are those of groups 1 and 2, as well as aluminum, and two transition metal ions, silver and zinc. Charges are not expressed when naming these ions. However, if there's any doubt in your mind whether a metal forms more than one cation, use a Roman numeral to indicate the charge. It's never wrong to do so, even though it may be unnecessary. An older method still widely used for distinguishing between charged ions of metal uses the endings us and ic to the roots of the Latin name. A ferrous ion, that's the lower number of charge. Ferric ion is the higher number of charge. Copper 1 would be the cuprous ion, copper 2 the cupric ion. Although we will rarely use these older names in the text, you might encounter them elsewhere. Cations formed from non-metal atoms have endings that end in -ium. Ammonium ion, hydronium ion. These two ions are the only ions of this kind that we'll encounter frequently in the text. The names and formulas of some common ions are shown in Table 2.4 and on the back inside cover of the text. The ions on the left side of Table 2.4 are the monoatomic ions that do not have more than one possible charge. Those on the right side are either polyatomic ions or cations with more than one possible charge. The mercury 1 ion is unusual because even though it is a metal ion, it is not monoatomic. It is called the mercury 1 ion because it is thought to have two mercury ions bound together. The cations that you will encounter most frequently are shown in bold-faced. You should learn these cations first. Table 2.4, common cations. Positive 1 charge, hydrogen ion, lithium ion, sodium ion, potassium ion, cesium ion, silver ion. Positive 1 polyatoms, copper 1 or cuprous ion, ammonium ion. Positive 2 ions, magnesium ion, calcium ion, strontium ion, barium ion, zinc ion, cadmium ion. Cobalt 2 or cobaltous ion, copper 2 or cupric ion, iron 2 or ferrous ion, manganese 2 or manganous ion, mercury 1 or mercurous ion, mercury 2 or mercuric ion, nickel 2 or nickelous ion, lead 2 or plumbous ion, tin 2 or stannous ion, chromium 3 or chromic ion, iron 3 or ferric ion. Number 2, anions. The names of the monoatomic anions are formed by replacing the ending of the name element with "ide". Hydride ion, oxide ion, nitride ion, from hydrogen, oxygen, nitrogen. A few polyatomic ions also have the ending "ide". Hydroxide, OH -1, cyanide, Cn -1, peroxide, O2 -2. Polyatomic ions containing oxygen have names in either ate or ite and are called oxyanions. The ate is used for the most common or representative oxyanion of an element, and ite is used for an oxyanion that has the same charge but one oxygen fewer. NO3 -1 nitrate, NO2 -1 nitrite, SO4 -2 sulfate, SO3 -2 sulfite. Prefixes are used when a series of oxyanions in an element extends to 4 numbers, as with the halogens. The prefix per indicates one more oxygen than the oxyanion ending in ate. Hypo indicates one oxygen atom fewer than the oxyanion ending in ite. This only goes with group 7. Perchlorate, ClO4 -1. Chlorate, ClO3 -1. Chlorite, ClO2 -1. Hypochlorite, ClO -1. Figure 2.25 can help you remember the charge and the number of oxyatoms in the various oxyanions. Notice that carbon and nitrogen both have 2 elements, the only 3 oxygen each, whereas period 3, phosphorus, sulfur, and chlorine have 4 atoms each. Beginning at the lower right in figure 225, note the ionic charge increases from right to left, from -1 for chlorate to -3 to phosphate. In the second period, the charges also increase from the right to left, from -1 to nitrate to -2 to carbonate. Notice also that each of the anions in figure 225 ends in ate. The perchlorate ion has a per prefix. Figure 225, common oxyanions. The composition and charges of common oxyanions are related to their location in the periodic table. Group 7, perchlorate ion. Group 6, sulfate ion. Group 5, nitrate ion, phosphate ion, carbonate ion. C. Anions derived by adding hydrogen to an oxyatom are named by adding it as a prefix word hydrogen or dihydrogen as appropriate. Carbonate ion, CO3 negative 2. Hydrogen carbonate or bicarbonate ion, HCO3 negative 1. Phosphate ion, PO4 negative 3. Dihydrogen phosphate ion, H2PO4 negative 1. Note that each proton added reduces the negative charge of the parent anion by 1. An older method for naming some of these ions was using the prefix bi. Thus, HCO3 is commonly called the bicarbonate, and HSO4 is sometimes called the bisulfate ion. The names and formulas of the common anions are listed in Table 2.5 and on the back inside cover of the text. Those anions whose name ends in "ide" are listed in the left portion of Table 2.5, and those whose names in "ate" are listed on the right. The most common of these ions are in boldface. You should learn the names and formulas derived from those ending in "ate" by removing The formulas of those ions whose names end in "ite" can be derived from those ending in "ate" by removing an oxygen atom. Notice the location of the monatomic ions in the periodic table. Those of group 7A always have a negative 1 charge, fluorine, chlorine, bromine, and iodine, and those in group 6 have negative 2, oxygen, oxide, and sulfide. Number 3, ionic compounds. Names of ionic compounds consist of the cation name followed by the anion name. Calcium chloride, aluminum nitrate, copper 2 perchlorate. In the chemical formulas for aluminum nitrate and copper 2 perchlorate, parentheses followed the appropriate subscripts are used because the compounds contain 2 or more polyatomic ions. Table 2.5, common anions. Hydrogen with a negative 1 charge is called hydride. F negative 1 fluoride, Cl minus 1 chloride, fluoride chloride, bromide ion, iodide ion, cyanide ion, hydroxide ion. Polyatomic ions, CH3COO, also C2H3O2 negative 1, acetate ion, ClO3 negative 1, chlorate ion, ClO4 negative 1, perchlorate ion, NO3 negative 1, nitrate ion, MnO4 negative 1, permanganate ion. Negative 2, oxide ion, peroxide ion, sulfide ion. Negative 2 polyatomic, CO3 negative 2 carbonate ion, CrO4 negative 2 chromate ion, Cr2O7 negative 2 dichromate ion, SO4 negative 2 sulfate ion, and number 3 negative is nitride ion, and the only polyatomic negative 3 is PO4 negative 3 phosphate ion. Names and formulas of acids. Acids are an important class of hydrogen-containing compounds, and they are named in a special way. For our present purposes, an acid is a substance whose molecules yield hydrogen ions when dissolved in water. When we encounter the chemical formula for an acid at this stage of the course, it will be written with H as the first element, as in HCl or H2SO4. An acid is composed of an anion connected to enough hydrogen ions to neutralize or balance the anion's charge. Thus, the sulfate ion requires 2 protons, 2 hydrogen ions, forming H2SO4. The name of the acid is related to the name of the anion, as summarized in Figure 226. Number 1. Acids containing anions whose names end in "ide" are named by changing "ide" to "ic" and adding the prefix hydro to the anion name and then following it with the word acid. Cl negative 1 chloride ion, hydrochloric acid. Sulfide anion, hydrosulfuric acid. Number 2. Acids containing anions whose name ends in ate or ite are named by changing ate to ic and ite to us and then adding the word acid. Prefixes in the anion named are retained in the name of the acid. ClO4-1 perchlorate, perchloric acid. ClO3-1 chlorate, chloric acid. ClO2-1 chlorite, chlorous acid. ClO-1 hypochlorite, hypochlorous acid. Figure 226. How anion names and acid names relate. The prefixes per and hypo are retained from going to the anion to the acid. Anything ending in ide, like chloride, goes to ic and adds hydro, hydro-ic. Anything that comes from ate goes to ic. So chlorate goes to chloric, perchlorate goes to perchloric. Anything that's ite goes to us. So chlorite goes to chlorous, hypochlorite goes to hypochlorous. Names and formulas of binary molecular compounds. The procedures used for naming binary two-element molecular compounds are similar to those used for naming ionic compounds. Number 1. The name of the element farther to the left in the periodic table, closest to the metals, is usually written first. An exception occurs when a compound contains oxygen and chlorine, bromine and iodine, any halogen except for fluorine, in which case oxygen is written last. If both elements in the same group, the lower one is named first. Number 3. The name of the second element is given the ide ending. Greek prefixes are used to indicate the number of atoms in which of each element. The prefix mono is never used with the first element. When the prefix ends in A or O and the name of the second element begins with a vowel, the A or the O of the prefix is often dropped. The following examples illustrate these rules. ClO2, dichlorine monoxide. N2O4, dinitrogen tetroxide. NF3, nitrogen trifluoride. P4S10, tetraphosphorus decasulfide. Rule 4 is necessary because we cannot predict formulas for the most molecular substances the way we can for ionic compounds. Molecular compounds that contain hydrogen and one other element are an important exception. These compounds can be treated as if they were neutral substances containing hydrogen ions and anions. Thus, you can predict the substance named hydrogen chloride has the formula HCl containing one hydrogen to balance the charge of one chloride. The name hydrogen chloride is used only for the pure compound. Water solutions of HCl are called hydrochloric acid. Similarly, the formula for hydrogen sulfide is H2S because two hydrogen ions are needed to balance the charge on the S-2. Table 2.6. Prefixes used in naming binary compounds formed between nonmetals. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, 10 is deca.